So you know about fundamental and derived quantities. Fundamental and derived quantities. Okay. So fundamental quantities, we will be having quantities like length, mass, time, electric current. Did I explain this? Temperature. These are fundamental physical quantities. Amount of substance, and luminous intensity. Okay, so units for these physical quantities are like this. For length, it is meter. Symbol for representation of the unit is m, small m. Mass is kilogram and representation is small kg. And time is second, yes. Electric current is ampere, denoted with capital A. Temperature, Kelvin, denoted with capital K. And amount of substance, unit is mole, denoted with MOL. And the luminous intensity is measured in units called candela and denoted with CD. Clear? Again, in this units, we have SI unit, CGS unit, and MKS unit. Okay, we call all these as system of units. System of units. So here whatever we have seen, these units are generally of SI units. Okay. SI unit is known as International System of Units. International System of Units. It means it is been true for every country. In every country, the units will be same in this. If you measure in this, understand? So in these units, if you express, everyone can understand because it is international system of units. Clear? So we go to next. Dimensions of a physical quantity. Dimensions of a physical quantity. Okay. So how we represent dimension is, dimension generally is expressed in a bracket with raised powers of mass, length, and time. Generally mass, length, and time. Apart from this mass, length, and time, you will be having temperature and electric current. But mostly all are being expressed in terms of mass, length, and time. So how do we define? Dimension of a physical quantity? It is the powers of fundamental quantities must be raised in order to express the given physical quantity. The powers of fundamental quantities must be raised in order to express the given fundamental quantity are called its dimensions. It means here physical quantities dimensions. Understood? For example, let us take force. So what are the dimensions of force? If I want to write dimensions for force, it is nothing but mass into acceleration. See, this all should be in fundamental quantities, powers of fundamental quantities. So here fundamental quantity, mass is a fundamental quantity, but acceleration is derived quantity. So again you need to convert this into fundamental quantity. That is mass into acceleration can be written as velocity by time, rate of change of velocity. Here velocity is again derived, but time is fundamental. So again you have to convert this mass into velocity is nothing but displacement by time, again by time. That is equal to mass into displacement by time square. Here displacement is nothing but length, fundamental quantity, mass, fundamental quantity, time, fundamental quantity. So here we are expressing the raised powers of the fundamental quantities of a given quantity. Then we have to write this in bracket. Mass is capital M, only one is there. S means length. For mass we represent with M, for length we represent with capital L, for time we represent with T, for temperature we represent with K, for electric current we represent with ampere A. So what all we know, the previous table, the same we are going to follow here. So M, only one M is there, so M power 1. S means length here, displacement, only one S is there. Now here by T square. So if I write this one, all should be in numerator only. So we can write it as T power minus 2. So for T we can write T power minus 2. So the dimensional formula for force is ml T power minus 2. ml T power minus 2. We represent it in a closed bracket. Understood? This is how we can write dimensions for any physical quantity. For any physical quantity we can write the dimension. Okay, now if I take volume, if I want to write dimensional formula for volume is nothing but volume is represented with the unit meter cube. Meter cube is the unit of volume. First we should write units. Here meter cube. Meter is the unit of length. So we write L power 3. In this volume we don't have any mass. So mass is not there, time is not there. Therefore we write M power 0, L power 3, T power 0.